Guess the value of the limit as x approaches infinity of x to the second over 2 to the x by evaluating the function f of x equals x to the second over 2 to the x for x equals all of these different x points. Then use a graph of f to support your guess. So now we need to see if we can figure out the value for y when we have all of these different x values. And then we're being told to use a graph of f to support our guess. So I'm going to make a table for this. And so if I have x, and I have y, and then we can put all these in. So we have 0, 1, all the way up to 10. Looks like I need to move my table over just a little bit. There we go. All right, so we could type this into our calculator and we could use the table feature of the calculator to find all of these. I'm going to put it in Desmos so that I can use Desmos to find all of these. So let me show you what that looks like and how to go about putting this in Desmos. So here's my Desmos screen. So what I'm going to do is put in my original equation. So the original equation was f of x. So I have y. F of x equals x to the second over 2 to the x. So you can see our graph right here. This is what our graph is going to look like in our Desmos window. So we can see our graph. So we know what we're ultimately looking towards. Now we're looking for x to be approaching infinity. So we can see it looks like it's going to be 0. So as this levels off right here, see, looks like it's going to be 0. But let's see if we can do some calculations and see if we can figure that out. So I'm going to input a table. Let me show you how to input a table into Desmos. So I have my equation typed in right here. So we need that first. We need our y equals x to the second over 2 to the x. Now we can come to this little plus right here and we can add a table. Now I want it to say x sub 1 because that is notating what x values we're going to use. And we're going to use a whole bunch of them. We have 0 all the way up to 10. And then we have 20. And we have 50. And we have 100. All right, I've got my x's in there. So now I need to set this aside. I don't want to have to go through and do each of these calculations. I want Desmos to do it for me. So what we're going to do is we're going to tell Desmos that we want our graph to be our x sub 1s. So all of the values listed in our x sub 1 column that it just erased on me. And we want it to be raised to the second. There we go. They're all back now. And we want to divide that by our 2 raised to the x sub 1. Now you can see it input a whole bunch of values for me. When you type these in, to get the x sub 1, all you do is you just type x and then type 1, and it will automatically put it as the subscript. If you want to do the exponent, then you just push raise to the with using the shift key and the number 6 to get your little caret, and then you can do raise to the second that way. You have to put the subscript on the x's, otherwise it will not register back to this list of x values that you already had. So you can see here, this is going to be our list of all of our values, and those are the values that we need to go and put in our table on the other screen. So let's switch back and we can put all of those values in, and then we'll come back. All right, so here's our table, and we can put in all of our values. So if we look at our value for 0, it looks like 0 was 0, 1 is 0.5, 2 is 1, 3 is 1.125, and so on as we go down the list. So let's see if we can put those in real quick. So we have 0. You could also just take a screen capture and copy and paste your table. It won't fit horizontally here. It would fit vertically, but if you wanted to do it that way, that would work as well. So I'm just going to put these in real quick. I'm gonna have to start writing sideways because these are going to not fit in my little boxes. Notice for 50, they started doing scientific notation. So 2 times 10 to the negative 12. That means that we would have 12 decimal places in front. So there would be 11 zeros in front here. And so I really don't want to write that all out. So scientific notation will work for this. And then for 100, 8 times 10 to the negative 27. So that means there's a line of 26 zeros in front of here, which is a lot of zeros. So hopefully we can agree that we are looking at the limit as x approaches infinity. Now, infinity is a huge number. We're only at 100. Infinity would be extremely large. You can't even fathom how large it would be. And we have our x to the second over 2 to the x. And it looks like we're already approaching that 0. And if we look over here at our graph validates that, where we're going a little curve up here, bit of a curve down, and then it looks like we're leveling off towards our 0. If we were to continue moving our graph this way, see here's our 20, and then keep going, see how it looks like it's staying towards that 0. So it's going to have our limit approaching 0 as we approach infinity going the whole way across. So let's try number 10. Use the graph to estimate all of the vertical and horizontal asymptotes of the curve. So here's our curve right here. And we're trying to use our graph to estimate all of the vertical and horizontal asymptotes. So if we're trying to estimate the vertical asymptotes, then that means that we're trying to figure out where we have infinity and negative infinity for our y. So if we look on here, it looks like we're going towards infinity right here. And it looks like we're going towards infinity here and negative infinity here. And it looks down here like we've got a little tiny piece maybe approaching, but it's okay because see, we have our infinity right here. So I think we'll be okay. So let's see what we've got. Let's see if we can do all of these different pieces. Now this gets kind of tricky because the graph is small. So let's see if we can draw in some dotted lines to help us out. So the first one looks like it's going to be about here. Well, here, let's do this. Let's put this over in our Desmos graph so you can see a bigger picture, and I'll show you what I mean. Here we go. Let's just graph this in. So we need to have in our numerator, we have x to the third. Let's put our y equals in front. In our denominator, we have x raised to the third. We have minus 2x and plus 1. There we go. So now you can see our graph a little bit better. Let me scroll this down. There we go. A little bit bigger picture than what we had over here. So if you look at this, we need our vertical asymptotes. Well, it looks like we're going to have a vertical asymptote right here. Here's 1. Here's 1.5. It looks like a little bit more than 1.5. So let's do negative 1.6. So our first one that we're noticing is right here. And it looks like that is going to be negative 1.6. About, we're estimating. So we'll say x equals negative 1.6. And then let's see what else we can see. Let's use our bigger graph. It's a little easier to look at. So it looks like we'll have another vertical asymptote right here. See it going down the side of this little piece that I was mentioning before? See right there? Well, here's 1. Here's a half. So I think that looks like about 0.6. See if we have any others. So let's see here. Let's go back to our bigger graph. Looks like there's another one on the other side right here. That's going to come down the other side of this little peak. So that looks like it's going to be at x equaling 1. So let's add that to our list right here. So x equals 1. So these would all be our vertical asymptotes. And then we need to consider our horizontal asymptotes. So if we want to look at our horizontal asymptotes, let's go back to our bigger graph again. It looks like right here, it's going to level out. See that? So it looks like right there at y equaling 1, it's going to level out and we're going to have our horizontal asymptote. So it looks like we have 3 vertical asymptotes and 1 horizontal asymptote for this one.